Welcome to 4.4, secant and cosecant. Now it turns out that secant and cosecant are pretty easy to graph as long as you are good at graphing sine and cosine. So let me show you how to do it. Alright, here I have a graph of sine. What is the reciprocal of sine? The reciprocal of sine is cosecant. So cosecant graph is the reciprocal of sine. That means that the cosecant graph will be undefined wherever sine is equal to 0. So the first step of graphing a cosecant graph is to put asymptotes wherever sine is equal to 0. One of the asymptotes is the y-axis. You don't actually need to draw a dotted line along your y-axis, but I'm doing that to just remind you that this is one of the asymptotes. Another vertical asymptote is at pi, because sine is 0 here. And then we have 2 pi. So any multiple of pi is where we see sine crossing the x-axis. So that means that any multiple of pi will be a domain restriction for cosecant. Okay, so then the next thing you need to do is you just place a dot at the top of any peak and another dot at the bottom of the troughs. Okay? And so what we're going to see is that cosecant x and sine x actually do intersect at one point. The reciprocal of 1 is 1, and the reciprocal of negative 1 is negative 1. At pi halves, the sine of pi halves is 1, so therefore the cosecant of pi halves is also 1. The sine of 3 pi halves is negative 1, so then the cosecant of 3 pi halves is also negative 1. And lastly, for your graph, all you have to do is piggyback on the peak and the trough, and you have your graph. So you draw these U shapes. They look a little like parabolas, except that parabolas will keep going infinitely to the right and the left, but these are going to be bounded between these vertical asymptotes. And then here's another U shape. And again, this graph has to be bounded between the vertical asymptotes. So draw something that looks a little like a parabola, but is going to be stuck between the asymptotes. And that's all you have to do. Now, you don't actually want the sine graph included in your picture. So if you want to draw the sine graph so you can piggyback off the sine graph, which is how I like to do it, you can use either a dotted line or a highlight or something that differentiates the sine graph from the graph you're actually graphing, which is cosecant. So I might have done this better had I made a bunch of little dotted lines here, etc. But I wanted you to be able to clearly see my sine graph. So either just make a really light sine graph or a dotted line sine graph or use a highlight or something so that your cosecant graph is clearly distinct from your sine graph. Now, to graph secant, it's identical. Do all of this, but with the cosine graph, and you have your secant graph. So now let's get to some myopen math problems. The first problem I want to look at is question number 6. Just like sine and cosine, secant and cosecant have a period of 2 pi. So when we need to find the period of this function, we will do it the same way that we found the period of cosine. So the period of this function is going to be 2 pi divided by the b value, which is 4. So then this will reduce to pi halves. Next, to find the horizontal shift, what we're going to do is factor out the 4, and when you factor out the 4 here, you can see that you have x minus 3, which tells us that we have a horizontal shift of 3 to the right. Three units to the right. Pretty simple. Over here, again, we have a b value, and we're going to have the same steps. We're going to take the period, we're going to take the default period of 2 pi and divide it by the b value, which in this case is 11 pi over 6. The pi's will cancel, and then since we're dividing by a fraction, that's the same as multiplying by the reciprocal, so that would give us 12 over 11. To get the horizontal shift, we're going to have to factor this. So to factor this, in order to figure out what this number turns into, you take this number right here and divide it by what you're factoring out. So if you divide 44 pi over 3 by 11 pi 6, it's the same as multiplying, and so you end up by the reciprocal, and so you end up with 88 pi over 11 pi, which is 8. So that means that the shift is 8 units to the right. Next, let's look at problem number 8. How do we figure out which graph this is? Well, first, I would factor this. So if you just take this part right here and factor out the 1/2, you end up with a shift to the right of pi halves. But it's helpful to also know what is the period of this graph in the first place. The period of this graph is going to have to be 2 pi divided by 1/2, so that is 4 pi. So we're looking for a graph that has a period of 4 pi. Now, if we're looking at each of these, we want to note that each of these have integers on their axis. So to find a period of 4 pi, we need to figure out what the approximation of that would be. We're looking for a period of about 12.57. From this point here to this point here, we are dealing with a distance of only about 7-ish. But that is half of a period. So we would want to double that to figure out the whole period. So that could possibly be correct. Over here also, we have about 7-ish. Here also, and here also, which means that every single one of these has an identical period that is actually matching this. So we can't figure out what the answer is just by paying attention to the period alone. All 4 graphs satisfy the period condition. So what would we look for next? Next we would look for the orientation, so we can eliminate half of them. You can look at any of these features in whatever order you want. Now the secant is the reciprocal of the cosine graph, and the cosine graph typically is going to start up high and end high. But with the negative out in front, what we're going to be looking for is a cosine graph that actually is going to be doing the reverse. Now, if you have a cosine graph that's doing this vertical reflection, that means that the secant graph you're looking for is going to be down low like this and up high like this, because it would piggyback off of all of the peaks and troughs of this turquoise function. So we're going to be looking for a graph that's going to match this, and this is going to be shifted to the right by pi halves. And pi halves is only 1 1/8 of the period. So we're going to look for this graph shifted over just a little bit. So 1/8 of the period would be about if these are the quarter cycles, 1/8 would be about that much. So this is about 1/8 of the period, not 1/8 necessarily on that mark on the axis, but 1/8 of a period. So I'm going to say 1/8 of the period. So we're looking for a graph that has shifted over just a smidge to the right. This one looks like it has been shifted to the left. This one is nowhere near the axis. This one nowhere near the axis. So this one right here best fits this. Okay, so pi halves to the right is the same thing as a little over 1, about 1.5, and that's actually where you see this right here. This graph is occurring here, which makes this our final answer. And there you go. You can see it right there. So another way of doing a question like this would be to go ahead and figure out on your own paper what this would look like before you try to match it up if this is overwhelming. So I would try graphing the corresponding cosine graph that looks just like this, and then you should be able to figure out where each of the problems are. That is challenging though, I do understand. So what I would say is before you do my open math problems, if they're too difficult or challenging for you to wrap your head around, go do some of the textbook graphing and then come back to my open math and see if you have a better understanding of how to graph. So let's go do that now. This problem is a lot easier than trying to graph the one from my open math. This is, I didn't tell you the problem number, number 12. This is number 12 on page 179. So the way that I graph secant is I first graph the corresponding cosine graph, and then I just piggyback off of the cosine graph, and voila, I have my secant graph. So what I want to do is in green, I'll graph the corresponding cosine graph. And this should be a nice review of how to graph cosine. So what I want to do first is make the observation that I have no vertical or horizontal shift. Setting up my y-axis is pretty easy when there's no vertical shift. I look at the amplitude, so my graph will go 2 above and 2 below. You do need to add some extra headroom and below room, though, for the fact that you are graphing secant, so you do need to have space above the 2 and below the 2. Next, what I want to do is check out the period. With a b value of 1/2, the period is 4 pi. So it's going to be like that. Okay. And this graph is over a 1-period interval. Quarter cycles for 4 pi are simply pi multiples. And my graph has a vertical reflection. So what I'm going to see is that my cosine graph starts here at -2, comes up to pi, reaches its peak here then at 2 pi, back down to 0 at 3 pi, and over here at 4 pi. Now, the vertical asymptotes for secant occur wherever cosine crosses the x-axis. So I'm going to have one of them right here, and another one right here. If you don't like the incomplete curves, you can always extend your graph beyond the 1 period required. If I want to keep going over here to 5 pi, I can finish off the cosine arc. So then I need another vertical asymptote over here at 5 pi. Or you could go to the left and finish off the cycle this way. At -pi, the cosine graph will come back up to 0. So I have another vertical asymptote here. So actually what I have here is 1.5 cycles, right? 1.5 periods, which is more than what I needed. You are never prohibited from graphing more than what's required. So to graph the secant graph, I just need to piggyback off of the peaks and troughs here. So I'm going to have a dot right here at the peak, and then it's going to go upward in a U shape. Keep between the vertical asymptotes. Over here, piggyback off the trough. Piggyback is not a technical math term, just something that I use. So you only needed 2 of these 3 U-shaped things to make one period. And technically you can even have, you could have stopped here and had 2 halves and 1 whole, as long as you end up with 1 full period somehow. That's number 12. All right, next one. So here is a cosecant graph in number 14, so I want to graph the corresponding sine graph for starters. So this graph has no vertical shift. So I can have my y-axis be labeled with the amplitude 1/2 and -1/2. The period of the graph is 2 pi because the b value is 1, and I am shifting over to the right pi halves, which is one of the quarter cycles. You can graph simply from 0 to 2 pi, or you can graph a little beyond that. I'm going to go ahead and go to 5 pi halves, because with this graph shifted to the right pi halves, here's the sine graph shifted to the right pi halves. And if you want to keep drawing it over here, you can. You can connect it as far as you want. If you want to stop right here, you can. I usually always like my graph to at least be touching the y-axis somewhere. So it bothers me if my graph is just over here and it doesn't extend all the way to the y-axis. You don't have to extend it all the way back to the y-axis, but it is nice to see what the y-intercept is. The vertical asymptotes for cosecant occur wherever sine is 0. And now we can just piggyback on any of these arcs. So we have from the peak and from the trough, these black curves are the graph of your cosecant. And so if you want to include this one over here, I have graphed actually 1.25 cycles here of cosecant. So as long as you have at least 1 period, graph as much as you need to fully demonstrate your understanding. So number 24 is a lot more complicated. We want to start by graphing the corresponding cosine function. Also, I'm going to rearrange the way this is written. I'm going to put the +2 afterwards. I like to shift that around. And then also I want to go ahead and factor out this 1/2. Okay, so for graphing this cosine, I do notice that I have a vertical shift up too. So when I'm putting in my vertical labels, keeping in mind that I have a 1/4 here, I want to use increments of 1/4. So, okay, if this is 2, then I'll have 1/4 notches This graph is going to oscillate between 2.25 and 1.75. going to draw this horizontal line here because the graph of cosine will oscillate above and below the 2. It will go 1/4 above and 1/4 below. So it's going to be a very, very skinny, narrow graph up here. Next, I want to make the observation that I have a period of 4 pi. My quarter cycles are then multiples of pi. So this is going to be about right here, here. Okay, so those little notches right there correspond to the x-axis notches. I put those in there for guidance here since I'm not using graph paper. And next I want to look at the horizontal shift. I'm shifting to the right by 2 pi, which is half of a cycle. So whereas cosine normally would start up high at 2 1/4, the up high is going to happen at half a cycle, which will be the same thing as just turning this into a vertical reflection. So if you take a sine or a cosine function and you shift it over half a cycle, it's the same as its reflection. Okay, so my cosine graph is going to go through these red dots here. Again, I'm going to use a nice dotted curve here to represent cosine. And then wherever you have a 0 of the function, you're going to have a vertical asymptote. But here, instead of looking for the zeros down on the x-axis, you're actually going to look for where they cross this midline. So my vertical asymptotes are going to occur at pi and 3 pi. And now I can piggyback off this curve for my secant graph. So 2 halves make a whole, and then another whole. That is one complete cycle right there. So work through them step by step, just as you did back in the sine and cosine shifting section. And this actually is a nice review then of getting to practice the sine and cosine a little bit more. So now let's go back to my open math. Okay, so here I have either a secant or a cosecant, and I need to figure out the equation for it. So what I would recommend you do is try to figure out where you have a midline for starters. Where is the halfway point? And I can see that I have a halfway point about at -1. So I'm going to just draw this -1 line here, and you can see then that the distance from the midline up to the bottom of the curve here is 2, and from the midline down to the top of this curve is 2. So that means that I know that I have a midline of y equals -1/2. And if I have a midline of y equals -1/2, that means that whatever my graph is, I shifted it down by 1. My next observation is that I have an amplitude of 2, right? Because if I go 2 above and 2 below from the midline, that means that my amplitude would have to be 2. And then the next observation I want to make is what is the period of this function? You can tell that going from here to here, which would be 1 full cycle, there is a distance of 3. So that means that my period is 3. That would mean that my b value is 2 pi/3. And lastly, I need to figure out is this cosecant or is it secant? And if I were to try to graph the curve that is the reciprocal function here, does this look like a cosine graph or does it look like a sine graph? Well, based off where it is intersecting the y-axis, this would be a cosine graph. So if I have a positive cosine graph as the reciprocal graph, that means that the graph that was originally graphed would have to be a secant graph. So it's a positive secant graph with an amplitude of 2. So I'm going to write 2 secant, and then I've got a b value of 2 pi thirds. I have no horizontal shift, thankfully. And then I have a vertical shift down 1. And now I'm going to check my answer. 2 secant 2 pi thirds x minus 1. Great! Now we move on to this next graph down here. So let's go through the same steps again. So for starters, I want to make the observation, where is my midline? And halfway between 0 and -4 is -2. So I see that I have a midline here at -2. Next, I can observe that the graph is 2 above and 2 below the midline. So as in the case of the previous problem, the amplitude is again going to be 2. For the period from this point, from here all the way to here, that's one full cycle. That's going from -pi to +pi, so that means that my period is 2 pi, which is your standard period. And I can see again that it's a cosine graph by the fact that it intersects up here. I'm drawing the reciprocal function in. It's a fill-in-the-blank kind of thought. If you can see where the reciprocal function is, then you can figure out a lot about this graph. Here I have a cosine graph with an amplitude of 2, shifted down to a standard period. So that means that when I'm putting the answer here, I should expect to see a 2 in front of a secant with a standard period shifted down 2. That would make your answer 2 secant x minus 2. So these are going to be the same type of questions, but we can work through those for further practice here. Look for the midline. Halfway between -1 and +3 is +1, so your midline here is at y equals 1. Then how high and how low below the line are you going? You're going above 2 and down 2. Again, we have an amplitude of 2. This is coincidental. Next, look for the period. I have from peak to peak or from trough to trough. Let's see, this is 4.5 pi, and this is -1.5. -1.5 to 4.5, that's a distance of 6 pi. So if your period is 6 pi, that means that your b value is 1/3. And lastly, is this a sine or is it a cosine graph? Well, I'm seeing a sine graph here. Since that's a positive sine graph, that means I'm going to have a cosecant for my answer. So I have an amplitude of 2. It's a positive cosecant. The b value is 1/3. I have shifted the graph up. I'm shifting the graph up 1. So 2 cosecant 1/3 x plus 1. Let's check to see if I'm right. There you go. And now question number 12 for our last problem. Start by finding the midline. Halfway between 4 and -2 is +1, so this one again is going to have a midline at y equals 1. This one is an amplitude of 3 instead of 2. So we are going 3 above 1, so the amplitude is 3. Similarly, we are also going 3 below 1, so that should be an identical distance from this trough of the function. We have a -1.5 to +4.5, which means the period is a plain old 6, which would make your b value pi-thirds. And the graph is going to be a sine graph again. So that would be a cosecant, a positive cosecant. A positive cosecant with an amplitude of 3, a b value of pi-thirds, and a shift up 1 is going to be this graph right here, 3 cosecant. This should be pi-thirds. I don't know why they wrote it as 2 pi over 6, because that's not reduced, but it's pi-thirds. X plus 1. And that is the lecture for today.